This is section 11.2.1 on permutations. Before we get into talking about permutations, we need to review factorials. Let's take a look at the examples that we have here, starting with number 1, which says 5 factorial. You may remember from previous math classes that whenever we do a factorial, we multiply the number times every number before it all the way down to 1. So in number 1, 5 factorial would be 5 times 4 times 3 times 2 times 1. Multiplying all these numbers together, we get 5 factorial to equal 120. Let's take a look at number 2. 9 factorial would be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now throwing all this into the calculator can be a little bit tedious. There's a factorial function on your calculator that you certainly can use. If you grab your calculator and you hit the math button and go all the way over to the right to where it says PRB, that stands for probability, the fourth option down is the factorial button. So on your calculator, if you go back to your home screen and push the number 9, then hit the math button, we'll go over to PRB, select number 4, that'll bring up 9 factorial on your home screen, hit enter, and you'll see that 9 factorial is equal to 362,880. Number 3, we have 0 factorial, and interestingly, 0 factorial always comes out to equal 1. Number 4, we have 3 factorial times 4 factorial. Now if we were to write this out, we would have 3 factorial, which is 3 times 2 times 1, times 4 factorial, which is 4 times 3 times 2 times 1. But what you could do with your calculator is you simply could enter 3 factorial, 4 factorial into your calculator. So either method, you're going to get the same answer, which ends up being 144. All right, number 5. Let's write this out to understand what's happening here, because it'll be important when we get to number 6. We have 26 factorial over 21 factorial. 26 factorial, 26 times 25 times 24 times 23 times 22 times 21 times 20, all the way down to 1. 21 factorial would be 21 times 20 times 19, all the way down to 1. Now, in the numerator, on top of this fraction, we have 20 factorial right there. Excuse me, we want 21 factorial. So we have 21 factorial right there. This 21 factorial in the numerator will cancel with the 21 factorial in the denominator. So we can cancel out all of that and all of this and simplify it to 26 times 25 times 24 times 23 times 22. You could enter that into your calculator and get your answer. Or, of course, you could enter 26 factorial into your calculator divided by 21 factorial. In either method, you'll come out with the same answer. $7,893,600. Now, the reason I showed you number 5 written out and canceling the 21 factorials in the numerator and denominator is because when you get to number 6, if you try to enter 500 factorial divided by 499 factorial into your calculator is not going to be able to do this. So you have to understand what's happening. Let me go through it again with number 6. So we know number 6 is going to be 500 times 499 times 498 times 497, multiplying all the way down to the number 1. In the denominator, we have 499 factorial, which would be 499 times 498 times 497, all the way down to 1. So hopefully you can see what's going to happen here. All the 499 factorial on top and bottom will cancel each other out, leaving us with 500 as our answer. Now, as we talk about permutations, we're going to need to understand factorial. That's why we are reviewing it here. All right, now we're ready to get into talking about permutations. So we're going to start with the definition. A permutation is an ordered arrangement of items that occurs when no item is used more than once, and the order of arrangement makes a difference. The definition here will become more clear as we go through some examples. Right? There is a formula for calculating permutations. Right? We read this part as the number of permutations of n objects taken r at a time. So n stands for the total number of objects in the scenario, and r stands for the number of objects that we're actually going to be arranging. The formula, n factorial over n minus r factorial. Now we really won't use this formula all that much because there's a permutation function on the calculator, which I'm going to explain on the next slide. It's important to also know that all permutation problems are also fundamental counting principle problems. So you can solve these using the fundamental counting principle. You'll remember from the previous video that when using the fundamental counting principle, we multiply all the options in each category to get the total number of possible outcomes. All right, next we're going to discuss using the permutation function on the calculator. So if you have a calculator in front of you, what you want to do is you want to hit your math button, which is right there. And whenever you hit that math button, this screen is going to come up. And again, if you go all the way over to the right to where it says PRB, this is the same screen that you got your factorial from. There's the factorial function. But look at number 2. Number 2 is the NPR, or the permutation of n objects taken r at a time. So this is what you would use. If you had a problem where you had 9 total objects and you were going to find out how many different ways you could arrange 4 of those 9 objects, you would enter this into your calculator. 9 NPR 4. So you would put the 9 on your home screen, then you would hit the math button, go over to PRB, and select number 2, which is the NPR, and then that would show up on your home screen, and then you would enter 4. Then hit enter on the calculator, and it will give you your answer, 3024. What this means is, if you have 9 total objects, and you want to find how many different ways you can arrange 4 of those 9 objects, there are 3024 different ways to arrange 4 out of 9 of those objects. So we're going to be using the calculator a lot here. So here's an example. There are 13 players on the team. You need to choose a batting order having 9 players. How many batting orders can you form? Well, first of all, let's go back to the definition of permutations to make sure we understand why this is a permutation problem. A permutation is an ordered arrangement of items. Certainly we are arranging the players in the batting order, where no item is used more than once. Of course, no batter can bat more than once without going through the whole team. And the order of arrangement makes a difference. Well, the order of arrangement in the batting order does make a difference. If you think about baseball or softball, usually your leadoff hitter is somebody that can get on base and is fast. Usually your third batter hits for a good average. Usually your fourth batter hits for power. Usually your pitcher, perhaps your worst hitter, bats last. So this is definitely a permutation problem. Now, we can answer this question two different ways. One way using the fundamental counting principle, where we take the number of options in each category or in each spot and we multiply them all together. So let's think about this as a fundamental counting principle problem first. There are 9 players in the batting order. So my 9 boxes represent the 9 spots in the batting order. We have 13 players on the team, so if I'm the coach, I can choose any of those 13 players to bat first. But now that one player is batting first, there are only 12 more players that could possibly bat second. Now that there are 2 players already in the batting order, that leaves me with 11 players, then 10, 9, 8, 7, 6, and the last spot in the batting order, I still have 5 players on the team to choose from to put there. So using the fundamental counting principle, I would multiply all these numbers together, and I would get the following number, 259,459,200. So that's 259,459,200 different possible batting orders for a team that has 13 players. That's a lot of different batting orders. All right, so we solved it as a fundamental counting principle problem. Now let's look at it as a permutation problem. All right, we've already explained why it's a permutation. Now let's think of it as the NPR, right? The total number of objects is N. It's a permutation. That's what the P stands for. R is the number of objects that we're going to choose. So we know that on this team we have 13 total players, and that 9 of them are going to be arranged in a batting order. So if you take your calculator, on the home screen, put 13, hit your math button, go over to PRB, select number 2, the permutation function, then put number 9 on your home screen and hit enter. And you can see that you're going to come out with the exact same answer. 259,459,200 different batting orders for 9 players in the batting order. This has been section 11.2.1 on permutations.